This is Momo. He's going to help us learn about mathematics. Have you ever wondered how computers are able to count? They use a system called binary, whereas you and I use a system called decimal. In some ways, computers are actually quite simple. Not as simple as Momo, but not as complicated as you. Why? Because they only count using 1 and 0. That is, computers are able to make every single number or every single quantity in the world using only these two symbols. As you probably know, we use 10 symbols to do our counting. We can use combinations of these symbols to represent any amount or any number in the world. And Momo can't count at all. Silly Momo. Let's quickly review how we count. We use 10 symbols, as I said before, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But what do we do when we want to count to something higher than 9? Well, you know that we write the number 10. You know how to write 10. But what we're actually doing here is using something called the column method. So with these two-digit numbers, the symbols on the left represent number of tens, and the symbols on the right represent number of ones. When we write 10 or 10, what we're actually writing is one lot of 10 and 0 lots of 1. You can think of this in terms of momos. One lot of 10 momo and 0 lots of 1 momo is equal to 10 momos. And we can think of any two-digit number like this. For example, the number 23. 2 tens and 3 ones, or 2 lots of 10 momo and 3 single momos. That's a total of 23 momos. So that's how we count, or the decimal system. But how do computers count things like number of momos? Computers count 0 and 1 just like us, but after they've gotten up to 1, they don't have any more symbols to use, so they need to move to the next column. Unlike our number system, in binary, the first symbol or column to the left represents groups of 2s instead of groups of 10s. So with two-digit numbers in binary, symbols on the right represent groups of 1 and symbols on the left represent groups of 2. 0 is 0 groups of 1, which is 0, and 1 is 1 group of 1, which is 1. How can we write 2 in binary? With one column, the highest number that computers can count to is 1. Just like with one column, the highest number that you and I can count to in decimal is 9. When we want to count to 10, we have to add another column to the left. Just like this, when computers want to count higher than 1, they have to add another symbol to the left as well. A 1 under the 2's column and a 0 under the 1's column gives us 1 lot of 2 and 0 lots of 1. 1 0 in binary is equal to 2 in decimal. Again, let's think of it in terms of Momo. 1 0 is 1 lot of 2 Momo and 0 lots of 1 Momo. That's 2 Momos altogether, so 1 0 in binary is equal to 2 in decimal. Can you guess how to get to 3 in binary? When converting decimal to binary, we always start looking at the leftmost column first. A 1 in the 2's column will get us up to 2 Momo, and then we just need one more in order to get to 3. So a 1 in the 1's column will give us this extra Momo that we need. 1 1 in binary, 1 lots of 2 plus 1 lot of 1 is equal to 3 in decimal. How do we write 4 in binary? Well, as you can see, we already have a 1 in both the left and the right columns, so 3 was the maximum number that we could write with 2 columns in binary. We need to add another column to the left in order to write the number after 3. And what do we write at the top of this column? We write 4s. So now we have our extra column to the left. How do we write 4? We add a 1 to the first column, which gives us 4 Momo, and that's the number we're after, so we can add a 0 to the remaining columns to the right. 1 0 0 in binary is equal to 4 in decimal. How do we write 5 in binary? You always start from the left-hand side. So starting from the left, 1 under the 4, we're still under 5. If we added another 2, that would be over 5, so we put a 0 in the second column. That gives us 4 momos so far. How many more do we need? We just need 1, so we put a 1 in the ones column. 1, 0, 1 in binary gives us 5. 1 lot of 4 and 1 lot of 1 momo gives us 5 altogether. 1, 0, 1 equals 5. Now let's try 6. How do we write 6 in binary? Well, again, start from your left-hand side, collect your momos. Starting with 4, 1 lot of 4 gives us 4 momo. If we add another 2, that's 1 lot of 2 gives us another 2 momo. Do we have enough yet? Well, 4 plus 2 is 6, which is the number that we're after. So yes, we can pop a 0 in the third column, and we have 6. In binary, 1, 1, 0 equals 6. Now for 7, starting in the left column, 1 under 4 gives us 4 momo. 1 under the 2 gives us another 2, bringing us up to 6 momo so far. And we just need 1 more momo, so 1 under the 1 column gives us 1 more, equaling 7 momo altogether. 111 in binary is equal to 7 in decimal. Okay, so we've successfully counted to 7 using binary. Have a break, rest your neurons, and watch Momo relax. Okay, so we're up to writing 7 in binary. 111 in binary, 1 group of 4 plus 1 group of 2 plus 1 group of 1 is equal to 7. And as you can see, we have a 1 in each column now, so 7 is the maximum number that we can write using 3 spaces or 3 columns in binary. So how do we write the number 8? Well, we need to add a 4th column, and we add it to the left as usual. And you can see if we put a 1 in that first column to the left, that will give us our total of 8, so we can add a 0 to the remaining columns to the right. So 1000 in binary is equal to 8 in decimal. 9 is just 1 more than 8, so 1 in the 8's column, then 00 and 1 under the 1 to give 1 more. So 1001 in binary is 9 in decimal. Okay, and we can get faster at doing these. So 10 is 2 more than 8. So 1 under the 8, 0 under the 4, 1 under the 2, because 8 plus 2 is 10, and then another 0 under the 1. 1010 is equal to 10. Okay, now for 11. So 11 is just 1 more than 10. So 101 gives us our 10, and then another 1 under the 1 gives us our extra 1. 1011 is 11. We should be getting the hang of this now, so let's jump right down to 15. Start with the left column. 1 under the 8 gives us 8. 1 under the 4 gives us 12. 1 under the 2 gets us right up to 14. We just need 1 more under the 1, and that gives us our 15. So 1111 is equal to 15. So we've now got a 1 in each column, which means that 15 is the maximum number we can write using 4 columns. We need to add another column to the left. And now I'd like you to notice that the numbers at the top of the columns seem to be following a pattern. Each number doubles as you move to the left. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Can you guess what the next column will be? So 8 times 2 is 16. So 16 is the next number in the next column to the left, but we knew this anyway because we got up to 15 using our 4 columns. Knowing the pattern, however, allows us to predict larger binary numbers without having to count up one at a time. You can see an example of this in the practice exam questions towards the end of the video. Also, for all of the really observant students, you can notice that each of the columns goes up in powers of 2. So 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and 2 to the power of 4 is 16. If you don't understand that last bit, don't worry at all. That's more advanced binary. Momo doesn't get it at all. Poor Momo. Okay, so this is a question you might get given in an exam. What is 10111 in decimal? So we're converting binary to decimal. The first thing we want to do is draw our columns, and we draw as many columns as digits that you're given in the binary number. So as you can see, we have 5 digits in this binary number, so we're going to start with 5 columns. If you had more than that, you just add columns to the left. What numbers do we write at the head of our columns? Well, we start on the right-hand side with ones, as you know, and then as we move to the left, we just double the number before. So 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16. And as I said, if you had more digits in your original binary number, you just continue to double the rows as you move to the left. Okay, so we have our columns ready to go with their headings, and all we do from here is move each of the numbers into their respective columns. So starting from the right, we pull the first one into the first column and move along to the left from there. And once we have all our numbers in their columns, all that's left to do is count up our groups of numbers, or count up our momos. So we have one group of 16 momo, plus 0 groups of 8 momo, plus 1 group of 4 momo, plus 1 group of 2 momo, plus 1 group of 1 momo. How many momos does that make altogether? If you count up the groups of numbers, or momos, we have 23 altogether. So 10111 in binary is 23 in decimal. Okay, let's try another type of question you might be asked in an exam. What is 14 in binary? This is a decimal to binary question. So again, start by writing up your columns. If you have trouble remembering what numbers to put at the head of each column, just remember that the rightmost column starts with 1, like with our number system, and each column to the left of this one doubles. So we have 1, 2, 4, 8, 16, and the next column would be 32, but for 14 we'll just use these columns. So we have our columns, and we now want to convert the number 14 to binary. But where do we put the first one, or the leading one? Well, as usual, we start from the left and we put the leading one in the first column as we move to the right that is less than or equal to the number that we're looking for. If we placed a 1 in the 16s column, that would give us 16, which is greater than 14, so it wouldn't be the correct binary sequence. How about the next column to the right? Well, that is 8, which is less than 14, so that's the column that our leading one goes into. Again, in terms of Momo, we have one lot of 8 Momo to begin with. So how many more do we need? Well, 14 minus 8 is 6. So we have to represent 6 using the remainder of the columns to the right, or if you want to think about it in terms of Momo, we have to collect another 6 Momos. So we look to the next column to the right to see if it's less than or equal to the number we're still trying to collect. 4 is less than 6, so we can place a 1 under the 4's column, and that gives us 12 Momo altogether so far. We just need 2 more Momos in order to reach 14. So a 1 under the 2's column gives us these extra 2 Momos, and we now have 8 plus 4 plus 2 equals 14 Momos altogether. Finally, once you've collected all your groups of numbers, or all your groups of momos equaling to the decimal number that you're looking for, you add a 0 to any columns that remain to the right. So our column of 1s gets a 0 assigned to it. Any columns to the left you don't need to worry about, so we don't need to worry about our column of 16s. So 1110 in binary is equal to 14 in decimal. So that's basics of binary done. And if you have any questions, please comment them below and I'll answer them for you. Happy studying!